In today's lesson, we will discuss how to use technology to simulate athletic performance. During the 2008-2009 regular season, Sidney Crosby took 230 shots on goal and made 33 of them, which is 13.9%. However, during the playoffs, he took 79 shots and made 15, which is 19%. These data show that his performance, as measured by goal percentage, was definitely better in the playoffs than in the regular season. We can use a random number generator to simulate Sidney Crosby's performance in the playoffs. We will use the numbers 1 to 1,000 to represent the outcomes of a shot on goal. Selecting a number from 1 to 139 represents making a goal, and selecting a number from 140 to 1,000 represents not making a goal, either missing the shot or having it blocked. We choose 139 because that is the same as 139 out of 1,000, which is the 13.9% chance that we found. If, for instance, you had 14%, you would only use 1 to 100 because you have 2 digits. If you had 15.65%, you would use 1 to 10,000 because you have 4 digits. We will now use the graphing calculator to randomly select 79 numbers from 1 to 1,000 and then identify each outcome as a made or missed goal. On your TI-84 calculator, you need to press Math, arrow over to Probability, and go down to number 5, Random Integer, and press Enter. Yours may show up like mine, with a lower and upper and an N, or you may just simply have random integer and an open parenthesis, in which case you will type in the numbers separated by commas. So we'll go from 1 to 1,000, and he took 79 shots on goal in the playoffs, so we'll use 79. And then you press Paste and Enter. We want to store these in a list to make it easier to see the numbers. So we're going to press Store, which is right above on your calculator. And then we're going to press List 1. To get List 1, you're going to press second and the number 1 and press Enter. There are our digits. If you were actually going to do this on the calculator, you would have to go across the entire line keeping track of all the numbers from 1 to 179. But we stored ours in a list. So you can go Stat. First thing I'm going to do is sort my list. So I'm going to go down to number 2, Sort, and I'm going to choose List 1 again, which is second, number 1, and press Enter. So now I can go Stat, Edit, and go over to List 1, and I can see all of my numbers. This makes it much easier to count how many are between 1 and 79, or 1 and 139, excuse me. So this would be all the way down to here. So I got 10 numbers out of the 79 that are between 1 and 139. That would simulate him making 10 shots on goal. Another option you have, which you will use in your investigation, is to do the entire simulation. If you go under Resources in your tree and go down to Website Resources, scroll down to Resources from the book. You will choose the W.H. Freeman website, which will bring up this menu. You'll scroll down under Statistical Applets to Proportion/Number of Successes Given Ability. And we know his ability was 13.9%, so in decimal form that is 0.139. He had 79 shots on goal in the playoffs, so we'll put 79. You always want to simulate 100 performances, and then simply press Add More Trials. and this will give us our dot plot of the results. If you would like to count so that you don't have to actually do it yourself, you can count the number of dots less than or equal to 13.9, and it will count them for you and tell you that you have 79 dots less than or equal to. You can also do greater than. So it says, what can we conclude about Crosby's clutch performance? Well, he scored 15 goals. So we want to look and see what he had that was more. So you can go back and see that he made 21 that were greater than or equal to his ability. And then of the 15, he still made 12 that were 15 or greater. So since 15 is within the simulation, it was not a clutch performance. Okay, do students prefer brand name cookies? A random sample of 30 high school students were asked to taste 2 unlabeled cookies and identify which cookie they preferred. One was a name brand cookie and the other one was store brand. The order that the 2 cookies were presented was determined at random using a coin flip. Of the 30 students, 19 preferred the name brand cookie and 11 preferred the store brand. If the 2 brands are equally preferred among the high school students, what percent would you expect to choose the name brand cookie? So this would be 50% because we have 2 possible outcomes. And 100 divided by 2 is 50. Make a graph to compare the expected percent of students who would choose the name brand cookie and the actual percent of students who choose the name brand cookie. So expected would be 50%. The actual percentage is 19 divided by 30, or 63.3%. So if you look at the graph, you can see that more students preferred the name brand than expected. Assuming that 50% of all students would choose the name brand cookie, how would you use a random number generator? So there are 2 digits in 50%. So we would say random integer, 1 to 100, so the same number of zeros as number of digits. And then we have 30 outcomes we need to look at. And then you need to say which percentage was preferred brand name. Remember, you're going by what you consider to be the ability or what you were given in this case, since there's no ability for cookies. So you would say where 1 to 50 represents brand, and 51 to 100 represents store. So they did 100 trials of the simulation. So it says, explain what information this dot plot provides. So you would say the dot plot shows the possible number of students who prefer name brand given that 50% prefer name brand. Based on the results of the simulation, is there convincing evidence that students prefer name brand cookies? If you go back to the simulation, you can see that 19 is within the range, so the answer would be no. So 19 is within the range. So it could have been random chance.